Hi everyone, Mrs. Velo here. In this video I'm going to be going over the first 4 slides of the Dalton's Law notes. So in the gas laws unit we've been talking about the properties of gases, and usually when they're in some type of container, and what is the volume, pressure, temperature of that container, and how do changing those variables impact the other variables. So up until this point, we've been talking about just one gas being present in a container or a chemical reaction happening that produces a gas. But what happens if there are 2 or even more gases in a container? How does that relate to the pressure? And this Dalton's law makes a lot of sense. Basically, your total pressure, which often we're going to represent as P sub T, so like a P with the subscript T for total pressure, is going to be equal to the sum, so adding up the pressure of each individual gas. So it could be like P1, I'm just giving them, or it could be like P gas. You could be more specific. I could say O2 and N2, okay? So we can use P to represent pressure and then a subscript to represent either the total pressure or specific pressures of each individual gas. So basically, the total pressure of a container that has multiple gases in it is the sum of, so adding up the pressures of each of those individual gases, which makes sense. So usually we'll refer to these as the partial pressure. So because each one of them is partial, like it's part of the total pressure. So your total pressure, PT, is going to be equal to each of the partial pressures added together. So that's adding up each individual gas's pressure that's in the container to get the total pressure. Now, of course, if you're doing this, you want to make sure that all of your units are the same, right? You can't add together different units for pressure. So let's say here we have a tank that contains 3 gases. So we have nitrogen gas, which has a pressure of 4 atm, oxygen gas, which has a pressure of 9 atm, and then helium gas, which has a pressure of 12 atm. What is the total pressure? So in atm. So I would add up those together. Now these are already all in atm, and I wanted the answer in atm, so I can add those all together to get the total pressure. Now if you have any different units for pressure, you're going to want to convert those. So go ahead and pause this video and try the question here on slide 4 on your own, and then unpause the video to see the correct answer. Okay, so in this question we have 3 gases, CO2, CO, so that's carbon dioxide, carbon monoxide, and hydrogen gas. So it looks like the total pressure, so instead of being given the individual pressures to find the total pressure, we're actually given the total pressure first. So the total pressure is equal to 434 torr. And then we have the pressure of CO and H2 are both 112 torr. So we have the pressure of CO, carbon monoxide, is 112 torr. And then we have the hydrogen gas, the pressure of H2, is also 112 torr. And then it says, what is the pressure of the CO2? So we're finding one of those partial pressures actually in ATM. So PCO2 is what we're solving for, and we want that in ATM. So remember, the equation is your total pressure is equal to the sum of each of those individual pressures. So these three added together will give us the total pressure. Now, we do want the final answer in ATM, but I'm going to make this a little bit easier on myself. Everything is already in torr. So you could convert all of these into ATM and then plug into the equation to solve for X. But what I'm going to do is I'm going to leave everything in torr. So I have my total pressure, 434 torr, equals now the pressure of each individual gas added together. So we had 112 torr for CO, which is the carbon monoxide. This is the total pressure. This is the pressure of the CO, plus 112 torr for the pressure of the H2, plus X. This is the pressure of the CO2, which is what we're trying to solve for. So I'm going to go ahead and add 112 plus 112. So I have 434, and these are all in torr, so we can add them together. So I have 434, and that's equal to these two added together, which is 224, and everything's in torr, plus X. So if I want to get X by itself, we're going to subtract 224 from either side. So 434 minus 224. So we get 210. Now, this is still in torr, but we wanted our final answer in ATM. So I'm going to do 1 picket fence, and I know 760 torr is equal to 1 ATM. This will be on your equation sheet and something that you would be provided. And we're going to go 4 significant figures, 2763 ATM. Now, you could have converted all of these into ATM by doing a picket fence for each one and then plugged it into the equation, and then your answer would have been an ATM. But I feel like this is a little less work because you're only doing 1 picket fence versus 3. And that would be your final answer.